We're now going to do a couple examples where we illustrate all of the laws of exponents that we just presented. In this particular example A, we have x to the fifth times y to the negative second power over x cubed y all raised to the second power. Now as you're about to approach this problem, what you want to do is think ahead a few steps to see where you're going. Clearly the denominator needs to be simplified first, and the reason it needs to be simplified first is because I have a product raised to an exponent. And what I need to do is apply this exponent to each factor in the parentheses. And so I'm going to write this as x cubed all raised to the second power times, well, it would be y to the first raised to the second power, but I think it's safe enough to write that as y squared right now. So now I have x to the fifth times y to the negative second power over, here I'm taking an exponent raising to an exponent. Remember, when you have an exponent to an exponent, you multiply. So I'm going to write this as 3 times 2, which is 6. So that gives me x to the sixth power times y squared. Now here's a situation where thinking ahead is going to pay some dividends for you. We have the same base here, x to the fifth divided by x to the sixth. Now I could rewrite this as x raised to the 5 minus 6 power, but if I do that, I will result in x to the negative 1 power, and then I'll have to get rid of that negative 1 exponent. Remember, if we have a to the m over a to the n, I could write that a to the m minus n, but another option for me was to write that as 1 over a to the n minus n. In other words, take 1 over the base raised to the denominator's exponent minus the numerator's exponent. The reason that that's a good move is because you'll get 1 over x to the, in this case, 6 minus 5, and then I won't have to deal with the negative exponent situation. So that's what I'm going to do for that particular expression. I'm going to write this as x raised to the 6 minus 5 exponent. Again, you don't have to recognize that that's going to be the case to get the right answer. It just saves you a couple steps. Think about whether or not that kind of a procedure will work well with my variable y. If I take y to the negative second minus 2, then I'm going to end up with a negative exponent. However, if I write this as 1 over y to the 2 minus negative 2, now I won't have to deal with the negative exponent situation. So we get 1 over x to the 6 minus 5 is x to the first, and then y to the 2 minus negative 2 is y to the 2 plus 2, or y to the fourth power. So thinking ahead a couple of steps paid some dividends for us in this first problem. Now let's deal with letter B. I have basically a fraction raised to an exponent. What I'm going to do here is I'm going to apply this exponent to each factor in the parentheses. The reason that I'm going to be doing this instead of, say, using that shortcut reciprocal formula where I could write this as 3y to the negative 1 over x to the negative third to the positive 2 power, is because then I'm going to still end up with negative exponents. If I do a negative exponent times a negative exponent, I'm going to get a positive result, which is what I always want. So I have x to the negative 3 raised to the negative second, which is going to be x to the sixth power. 3 to the negative second power is going to have to be dealt with, so it's going to come up to the numerator as 3 to the positive second power. And here I have y to the negative 1 raised to the negative 2, which is going to be y to the second power, because when you have an exponent to an exponent, you multiply. So the one final step is to simplify 3 squared, which of course is 9, x to the sixth over y squared. So I guess the moral of the story here is it's not a bad idea to put some forethought into the steps you're going to follow before just jumping right into the application of the formulas.